The purpose of this lab was to observe and predict the properties of charged objects in electric fields. To study the behavior of charged objects, a real-world model consisting of two charged tapes being brought close to each other was used, as well as a coded simulation of the real-world model. I used Coulomb's law, which related the electric force of one object on another to the charges of both objects and the distance between them. Additionally, I used Newton's second law to explain the behavior of the tape's motion and predict the magnitude of the electric force on each piece of tape. In the end, I found that the laws of forces and Coulomb's law could be used to estimate the charge on each object. For the real-world model, I stuck two 20-centimeter pieces of tape together and ripped them apart to create a negatively charged piece of tape. I then did this with a second piece of tape. Each piece of tape had a mass of 0.2 grams. Next, I placed one charged tape on two surfaces with a space underneath the middle. Then, I held the other charged tape onto the first one, causing the first tape to rise upwards by distance. I measured the distance between the two charged pieces of tapes to be 1.2 centimeters or 0.012 meters. Using the data I gained from the real-world model, I coded a simulation of the model that would calculate the charge of each piece of tape. For the constants, I added the values of Coulomb's constant, acceleration of gravity on Earth's surface, the mass of each piece of tape in kilograms, and the distance between the charged tapes in meters. Next, I calculated the value of the electric force. Since the tapes had zero change in momentum, their net force was zero. This fact was used to determine that the electric force was equal and opposite to the gravitational force. Next, I calculated the charge of each piece of tape. For this, I used Coulomb's law and assumed that each piece of tape was a point charge and had equal charges. Finally, I used Newton's second law to simulate the motions of each piece of tape. The results in the real-world model are very similar to the results in the coded model. This is mostly due to how most values used in the code were gathered from the real-world model. Differences in the real-world model are likely due to the tape acting as a real object instead of a point in space. In the experiment, there were possible sources of error. One error is that I did not account for forces other than gravity and electric force. For example, there could have been drag. Another source of error comes from the assumption of the tape acting like a point charge. What if electrons had positive charge and protons had negative charge? What would change about the observations I made with the tapes and other charged objects? Well, the behavior of the objects would not change, as they would continue to be like charged objects and repel each other. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with my hands or other objects? It is important to handle the charged tapes as little as possible because doing so could affect the charges of the tapes. For the experiment, I needed the tapes to be the same charge. In conclusion, this lab shows how Coulomb's law and Newton's second law can be used to predict the behavior of charged objects.